Hello everyone, I'm Shreya JC from Sri Venkateswara College of Engineering, Department of Electronics and Communication, and now I'm going to discuss about civil engineering. So firstly, what is civil engineering? Civil engineering is the oldest, broadest and simple. It mainly related to planning, analysis, design, construction and maintenance of buildings, roads, bridges, dams, tunnels and other structures by the use of physical laws and mathematical equation and theory of mechanics. So now we'll discuss about scope of civil engineering. Scope of civil engineering containing 9 elements: surveying, structural engineering, geotechnical engineering, hydraulics and water resource, transport engineering, environmental engineering, construction planning and project management, earthquake engineering, remote sensing and GIS. So firstly, what is surveying? It is a science or art of map making. It mainly deals with various types of measurements and plotting of maps. Unless maps are drawn, no development work and construction can be undertaken. Earlier, traditional instruments used for surveying are chain, tape, leveling instruments, etc. Modern instruments are distance meter, total station, theodolite, etc. The second scope of civil engineering is structural engineering. It mainly deals with analysis and design of various structures like steel structures, trusses in industrial building, towers, etc., concrete structures, building, bridges, dams, etc. Analysis. Determining the internal force or stress developed in structural components of any structures due to applied load is called as analysis. Example, structural components in building are beam column. Design. Fixing suitable dimension for structural component of any structure using various methods is called as design. Example, load acting on a structure is transferred to ground through beam, column, foundation, etc. Later, I will discuss about beam, foundation, and column. The next one is geotechnical engineering. It mainly deals with the study of soil, types of soil, and properties of soil. Soil property changes from place to place, layer to layer. The study with properties and behavior of soil under loads or change in environmental condition is called geotechnical engineering. Geotechnical engineers analyze the soil to determine its suitability to support extreme loads. Proper geotechnical engineering is essential for a safe and secure structure. The fourth scope of civil engineering is hydraulics and water resource. Hydraulics. As we know, water is very important need for all human beings. It mainly deals with the study of mechanics of water and its characteristics like pipe flow, open channel flow, dams, irrigation, hydropower, etc. Water resource. Water resources are natural resources of water that are potentially useful for humans. For example, as a source of drinking water supply or irrigation water. It deals with storage of water and supplying water to agricultural field, to drinking purpose and to other domestic or industrial uses. Hence, suitable water resources are identified and it is stored. And the next one is transport engineering. It plays a very important role in economic development of country. It mainly related with the study of existing transport system and improvement for safe drive. It mainly include design, construction and management of roads, railways, navigation and air roads. Various modes of transportation are roadways, railways, airways, and waterways. Traffic management, including traffic signals, number of lanes, parking facilities, and curves, are also a part of transportation engineering. And the sixth scope of civil engineering is environmental engineering. This is an important branch of civil engineering which covers both water supply and sanitary engineering. The main aim of environmental engineering is to keep environment clean. The environmental engineering encompasses the subject of treatment of waste which originate from different sources. The impact of waste originate from industry is felt by living organisms if such waste contain toxic substances. The central government as well as state government have enacted laws for protection of environment needed for safe living of human beings. The seventh scope of civil engineering is construction planning and project management. So, firstly, construction planning. It deals with different types of construction of structures like buildings, roads, bridges, etc. Construction of underground tunnel using modern equipments, construction of floating structures, it mainly include excavation of soil, construction of foundation, concreting, finishing, etc. And next one is project management. Deals with planning, scheduling, and execution of construction activity related to a project, comprises of material, time, and money management, planning for construction equipments and machinery for construction project. And the eighth scope of civil engineering is earthquake engineering. An earthquake is a sudden and rapid shaking of ground due to passage of vibration. The study of earthquake is called as seismology. Earthquake with magnitude of about 2 or less, usually called micro earthquakes, are generally recorded only on local seismograph. Events with magnitude 4.5 or greater are stronger enough to be recorded by sensitive seismographs all over the world. Great earthquakes have magnitude of 8 or higher. And the last scope of civil engineering is remote sensing and GIS. GIS and remote sensing techniques have become essential and powerful tools for tracking civil engineering problems. The majority of remote sensing systems use the sun's radiation. Remote sensing is art and science of gathering information about items, events or areas without physically touching them. It deals with measurement, mapping, monitoring, and modeling of graphic information around us. And let's discuss about types of materials used in construction. The types of materials used in construction are bricks, cement, mortars, plain concrete, reinforced and pre-stressed concrete, structural steel, and construction chemical. So first one is brick. Bricks are obtained by molding of clay in rectangular blocks of uniform size and then by drying and burning these blocks. As bricks are of uniform size, they can be properly arranged light in weight and hence bricks replace stones. Classification of bricks. Unburnt bricks and burnt bricks. And first one is unburnt bricks or sun-dried bricks. Unburnt or sun-dried with the help of heat received from sun after the process of molding. These are used for temporary and cheap structures. Such bricks should not be used at places exposed to heavy rains. And the second one is burnt bricks. The bricks used in construction works are burnt bricks. These are classified into three categories: first class bricks, second class bricks, and third class bricks. So I will discuss about first class bricks. Uniform red or brownish colored, high crushing strength, not less than 10.7 Newton per meter square. Machine molded, efflorescence is nil. Water absorption is less than 15%. And use of first class bricks are, they are used for exterior wall bricks, short columns and arches. And second class bricks, uniform colored but slightly overburnt, high crushing strength, not less than 7 Newton per meter square, hand molding, efflorescence is little, water absorption is less than 20%, use of second class bricks, they are usually internal walls and compound walls. And the last one is third class bricks, overburnt and non-uniform color, high crushing strength, not less than 3.5 Newton per meter square, hand molding, efflorescence is more, water absorption is less than 25%, they are used for flooring and paving. And these are the images of first class, second class, and third class bricks. Cement. A cement is a binder, a substance used for construction that sets hardness and binds them together. Grades of cement. Grade of cement is generally indicates the strength of cement. The strength of cement is generally measured as a compressive strength. There are three types in grades of cement. The first one is 33 grade cement. 33 grade cement means compressive strength of cement after 28 days is 33 Newton per meter square. And the second one is 43 grade cement. 43 grade cement means compressive strength of cement after 28 days is 43 Newton per meter square. And the third one is 53 grade cement. 53 grade cement means compressive strength of cement after 28 days is 53 Newton per meter square. And types of cement. There are mainly three types of cement. The first one is ordinary Portland cement. It is also known as OPC type of cement that is manufactured and used worldwide. OPC cements are available in three grades such as 33, 43, 53. And the second type of cement is Portland Pozzola cement. It is prepared by grinding fly ash with Portland cement. It is also produced by adding of gypsum or calcium sulfate. It is uniformly bended Portland cement and fine Pozzola. The third type of cement is Portland slag cement. It is a type of Portland cement obtained by mixing Portland cement, clinker, and gypsum with granule blast furnace slag in suitable proportions and grinding them into a through and intimate mixture. And the third one is mortar. Mortar is a mixture of cement, sand, and water. Uses of mortar. It is used in between joints of bricks during construction of wall. Used for repair of cracks. It is used for molding to form joints of pipes. The fourth one is concrete. Concrete is obtained by mixing cement, fine aggregate sand, coarse aggregate crushed stone, and water in definite proportion. Types of cement concrete. Plain cement concrete. Plain cement concrete is a construction material composed of cement, fine aggregate, and coarse aggregate mixed with water, which hardness with time. The types of plain cement concrete. Normal strength concrete. It is obtained by mixing ingredients, cement, water, and aggregate will give normal strength concrete. The normal strength has an initial setting time of 30 to 90 minutes that is depend on time properties, weather condition of construction site. Lightweight concrete. Concrete that have density less than 1920 kg per meter cube will categorize it as lower weight concrete. It is applicable for protection of steel structures and are also used for construction of long span bridges. It is also used for construction of building blocks. High density concrete. The concrete that have high density ranging between 3000 to 4000 kg per meter cube called as high density concrete. Crushed rocks are used as coarse aggregate. These are used in construction of atomic power plant and similar projects. And air entrained concrete. In this air entrained for an amount of 3 to 6% of concrete. Some examples of air entraining. Some examples of air entraining agents are resins, alcohols, and fatty acids. High strength concrete. They have high strength greater than 40 MP and they can be termed as high strength concrete. This increases the strength of achieved by decreasing the water cement ratio even lower than 0.35. And the last type is high performance concrete. These concrete perform to a particular standard but in no case will be limited to strength. It has to be noticed that all the high strength concrete can be high performance type, but not all high performance concrete are high strength concrete. Reinforced cement concrete. It is a very high compressive strength but low in tensile strength. It has least chances of buckling and rusting. It is used for construction on a large scale, such as bridges, dams, tall buildings. It is used for paving in airports, roads, and high traffic areas. It is used for constructing various structures like water tank, dams, bins, bunkers. Prestressor concrete. Prestressor can reduce volume of concrete required in construction, lowering the use and transportation of material. It has more advantages over reinforced concrete. It costs high. And the fifth material used for construction is steel. Steel is an alloy of iron and carbon containing carbon from 0.25 to 1.25%, and steel is highly elastic, malleable. Types of steel: mild steel, tar steel, high tensile steel. So, firstly, mild steel. It is a plain carbon steel greater than 0.25% of alloy is present. It is low priced. And the second type is tar steel. These are high strength. They are deformed after heat treatment. It prevents rust. And the third one is high tensile steel. It is a kind of mild carbon steel. It contains destructive allowing components to build tensile strength of steel. It is having high level of carbon. And the last one is construction chemicals. So firstly, adhesives. These are rich bonding property apart from weatherproof and waterproof. They are widely used in all types of construction works, which include tile fixing and floor covering, sealants and caulks. They are used to block an opening surface or small crack to prevent liquid or moisture leakage that damage the construction. Epoxy grouts. They are used for grouting and high durability property and applied in extremely high temperature. Admixtures. They are used to modify the flow characteristics, strength, and durability of concrete. And the next topic, structural elements of a building. The first one is foundation. A foundation is the lowest part of building structure, resting all soil below ground level. Types of foundation. Shallow foundation, deep foundation. Shallow foundation. Individual footing or isolated footing, combined footing, strip footing, mat foundation. Deep foundation. Pile foundation, drilled shafts. And this is the picture of foundation. Next one is plinth. The plinth is the foundation constructed either at or above the ground. It is made by constructing a brick or stone wall. It is constructed by RCC beam called plinth beam. Its main function is to prevent entry of moisture from ground to build superstructure. Lintel. Lintel are constructed above wall opening like door, window, etc. They are constructed by reinforced cement concrete. Its main function is to support weight of wall coming over the opening. Types of lintel: timber lintel, stone lintel, steel lintel, RCC lintel, reinforced brick lintel. And the fourth one is seja. This is a structure that is generally constructed above the window and projected outside from the window face. They are also provided above the doors. Advantages of providing seja. It protects the house from external sunlight. It protects the house by providing a barrier for rain water to enter. It is used to place the compressor of AC. It protects wooden window from rain and sun. And the next one is masonry wall. Walls are vertical elements of a building which support the roof. It is constructed by using stone, concrete blocks, bricks, etc. Its main function is to provide enclosure and protect against wind, sunshine, rain, etc. Main components of masonry walls: masonry units, masonry mortar. Masonry units containing mud bricks, cement concrete bricks, hollow bricks, and masonry mortar consists of mortar is used between the joints of brick layer. Types of masonry walls: load-bearing masonry walls, reinforced masonry wall, hollow masonry wall, composite masonry wall, precast masonry wall. And the sixth one is columns. Columns are vertical members constructed above the ground level to support any structure frame. Types of columns: rectangular column, circular column, short column, long column, axially loaded column, column with uniaxial eccentric loading, column with biaxial eccentric loading, composite column. And the seventh one is beam. Beam is a horizontal structural member used to carry vertical load, shear load, and sometimes horizontal load. It is the major component of building structures. Types of beams. Based on geometry, there are three types of beams. They are straight beam, curved beam, and tapered beam. And based on material, types of beam are timber beam, reinforced concrete beam, steel beam. And based on cross section, rectangular beam, T beam, and I beam. Based on type of support, there are five types of beam: simply supported beam, fixed beam, continuous beam, cantilever beam, overhanging beam. And the eighth one is slabs. Slabs are constructed to provide flat surface, usually horizontal in building floors, roofs, bridges, and other type of structures. Types of slabs: one-way slab, two-way slab, flat slab, grid slab, precast slab, composite slab, hollow core slab, sunken slab, waste slab, and projected slab. And the last one is staircase. A staircase is a sequence of steps that connects different floors in a building structures. The space occupied by stair is called as stairway. Stairs can be constructed by wood, steel, bricks, or stones, RCC, etc. Types of stairs: straight stair, dog-legged stair, open navel stair, circular stair, spiral stair, bifurcated stair. Thank you for watching my video.